This is the overview to the first and second laws of thermodynamics. So the first law of thermodynamics says that we can follow energy. We know where it goes from one form to the next. So when we talk about energy on the planet, we have concentrations of energy in things like food or gasoline or behind a dam or wood. And most of these things, the energy comes originally from the sun in the process of photosynthesis or in wind and weather that's caused by the sun. And so thermodynamics is the movement of energy or the flow of energy. And when we're talking about heat, we're talking about heat energy. So when we talk about thermodynamics in the first law of thermodynamics, we like to say that we know where heat goes. And the second law of thermodynamics tells us that it goes from high to low. So the first law of thermodynamics is going to allow us to quantify the types of energy that we have. So the first law of thermodynamics is an equation. That's the first law. And the first law of thermodynamics is the amount of internal energy that an object has will be related to the amount of heat that is added or subtracted and the amount of work that it does or is done onto it. So U is the amount of internal energy that something has. And so that is kind of like what's inside of it. And then the Q is the amount of heat that can either go into or out of. So for instance, in a fire, the energy, Q, would come out of the wood. When you digest food, the energy would come out of the food. Heat energy is coming out of the sun. And of course, in a car, the energy from the gasoline is coming out of the gas. So what that would do, and specifically in the case of the car, is that would allow the engine, or the inside of the engine, inside the pistons, inside the cylinders, to heat up. And that allows us to do work. So the first law of thermodynamics says that we can follow where this heat energy is going. Now, the answer to where it goes in the end can be summed up by thinking about dirt. Dirt is basically all the energy is spread out evenly. So if you were looking at an apple sitting in the dirt, you might eat the apple as a source of energy. It's concentrated. But over time the apple can decay and it can be spread out among the dirt. And you wouldn't get any energy or very little energy from that dirt. So energy when it's concentrated is a useful form for us. And energy when it's spread out is not useful. It's very difficult to get energy out of something like dirt because all the energy is spread out evenly. So the second law of thermodynamics says that heat energy is going to go from areas where there's high energy to areas where there's low energy, or areas where there's high heat to areas where there's low heat. So the dam is a very good example of this because this is actually higher in the mountain than the bottom of the dam. So when the water drops through the dam, we say we know this water is going to go downhill from high to low. And so engineers say, I wonder if we can find a way to make this work for us, do some work for us. Since it's going to go downhill anyway, can we capture that energy? And so they do. They capture it in the form of electricity. And when they capture this in the form of electricity, it can do some work. So that is employing the idea of the second law of thermodynamics. And the second law of thermodynamics basically says that the amount of work that you can get is related to that difference of energy. So we have a high energy and we have a low energy. And the greater the difference here, the greater the amount of work we can get. Just like if we had a dam and we had a high end of the dam and a low end of the dam, the higher it is, the greater the work we can get out of the dam. So the same thing is true for thermal energy. We have high temperatures and we have low temperatures. And the greater the difference between the high temperature and low temperature, the greater the amount of work we can do. So this pretty much sums up the whole idea of thermodynamics. In the end, this energy, work, heat, internal energy, if we just let it go to its end, it will be perfectly spread out. And that is where energy goes. Energy is neither created nor destroyed. It just pretty much spreads out, and there will be the wiggling of molecules. And so when heat is released from any process, a gasoline engine, etc., it is going to cause heat to be released, and that will result in just the basic wiggling of molecules.